This problem was to draw the stereoisomers of 4-methyl to nonene. So this is an alkene. Uh, the base name has non. That means there are 9 carbon atoms on the carbon skeleton. Okay, let's first draw the carbon skeleton. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's number the chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it has a double bond at the number 2 carbon, because this is 2 nonene means double bond as number 2 carbon. So there's a double bond here, and there is a methyl group at the number 4. There's a methyl group here. The problem was to draw the stereoisomers. So what are stereoisomers? Stereoisomers are the molecules, they have the same connectivity but the different arrangement in the space. So if you consider this molecule, there's a double bond here, therefore we have to consider EC EC arrangement here, and there's also a chiral carbon atom here. It attached to 4 different groups. Therefore there is a R and S configuration here. Okay, let's see first E E arrangement. So let's see the E arrangement around the double bond. So do you remember what is the E arrangement? So when we assign in the E and C configuration, we have to consider the groups around the double bond. So here there's a methyl group, and here there is a hydrogen atom here, and uh, there is another hydrogen atom here. Now let's assign the priority to the groups. So before assign, let's divide the double bond in the middle, so two different sides. So if you consider this left, if you consider the left side, there is a if you consider this left side, there's a hydrogen atom here and there's a methyl group here. So methyl group has methyl group has higher priority, therefore this is 1, 2. And the other side, the same thing, the hydrogen has lower priority, and other group has a hydrogen has a lower priority and other has the higher priority. Here 1, 2. Now look, the two ones are on the opposite side, therefore this is E configuration. How about the C configuration? To have the C configuration, the higher priority group should be on the same side. So I draw the methyl group in the other side. Now here, so this has a hydrogen and this has a hydrogen. Now let's assign the priorities. This group methyl has more priority than hydrogen, therefore 1, 2. Again this group has more priority than hydrogen, 2. Now higher priority groups are in the same side, therefore this is C configuration. Okay, now we assign the E and C, but now let's see how to do the R and R and S configuration. So we have to assign here maybe R or S, and the same thing here maybe R or S. Do you remember how do we show the RS configuration? You can use either wedge or dash to show the groups whether they are uh, out of plane or they are going into the plane. Okay, let's see the R and S configuration. Okay, so uh, with the E configuration, so you can the methyl group you can write as a wedge. Then here the methyl group. If this is come out of the plane, then the hydrogen atom go into the plane, or uh, the other way. If the methyl group go into the plane, the hydrogen is comes uh, uh, out of the plane. So with the E configuration, we have two more configuration. One may be R and other one may be the S. So we will see how to assign the R and S. The same thing for the here for the C configuration. The methyl group can come out of the plane. If it's out of the plane, then hydrogen go into the plane. And here, if methyl group go into the plane, then hydrogen come out of the plane. Okay, let's assign R and S configuration. So do you remember how to assign R and S? So when we assign the R and S configuration, we have to assign the priorities to the each group. So all of you know the hydrogen has the lowest atomic weight, so it has the lowest priority. So here the priority of hydrogen atom is 4. Now let's assign the priorities to the other three groups. So here is the methyl group, and here is a group with the 5 carbon atoms, and there is the alkyl. So let's see this group, the carbon with the 5 carbon atoms. So I can write it as a CHH and CH2 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 CH3. Then the other side it has a CH and then double bond CH CH3. So if you have group like this, so so when you assign the priority, first you have to go to the first atom. If you go from this stereogenic carbon atom to this one, the first finding atom is carbon, and this group also carbon, this one also carbon. But the methyl group, let me draw the methyl group. Hydrogen, hydrogen, hydrogen. If you go to the now all three groups, the first point difference is the carbon. All three has to connect to the carbon. If it's all connect to the carbon, then we have to go to the second point difference. The methyl group, it has a 3 hydrogen atoms attached to the carbon. Here there is a 2 hydrogen atoms and 1 carbon. Therefore this group has more priority than the methyl group. How about the alkene double bond containing group? So if there is a double bond, we can consider it has this carbon is connected to an, another carbon atom, and this double bond, this carbon is connected to another carbon atom. So therefore this group, it's attached to the 1 hydrogen and 2 carbon atoms. This one carbon, 2 hydrogen, methyl, 3 hydrogen atoms. Therefore if you assign the priorities, the first priority is going to this double bond uh, carbon. So this has the first priority, then this is the second priority, this is the third one. So you can write here 1, here 2, and methyl group is 3. Okay, now let's uh, draw the arrow go from 1 to 3. So if you consider 1 to 3, so arrow is go to this way, It means counterclockwise. If it counterclockwise, then the arrangement is S. So do you remember first we have to uh, point the lowest product group is into the plane, but it's already into the plane. Hydrogen therefore lowest product group is into the plane. Now then we assign the priority to each other groups. Then we draw a arrow from 1 to 3. So if when you draw the arrow 1 to 3, it's go to counterclockwise, therefore it is a S configuration. So if this one is a S configuration, this one should be R configuration. The same thing here. If you assign the priorities, the double bond one containing number 1, this is number 2, methyl group is number 3, and hydrogen is number 4. So again, when you connect 1 to 3, so it's going this way. So therefore this is S configuration. If this is S, this should be R configuration. So if you want, you can get the configuration of this, but look here, it has a hydrogen is come out of the plane and methyl group is going to the plane. Therefore we have to rearrange this molecule to uh, move the lowest priority group into the plane. So how do you do that? So let's rotate the molecule in this axis 180 degrees. Then this big group come to the left side and this alkene goes to the right side. And then this methyl group come out of the plane, then hydrogen move into the plane. Here the hydrogen go into the plane. When you rotate 108 degrees, methyl group come out of the plane, and these two groups also switch. Okay, now let's assign the priorities. Now here 1, this side is 2, this side is 3. Now let's connect 1 to 3. So now if you go 1 to 3, it's go like this way. This means clockwise. Therefore this is R configuration. Therefore with the E, there is two possibilities. One is R, other is S. One is S, other is R, and the same thing with the C configuration. One is S, and other one is the R. Okay, let's see. Let's write the name of these compounds now. So this has in the second one. This is 2E and 4S. 4-methyl non 2E. This one, because it's a E configuration as number 2 carbon, and the S configuration as the 4th carbon, and this one is 2E 4R 4-methyl non 2E, and this one is a C configuration. Therefore 2C 4S 4-methyl non 2E, and this one is a 2C 4R 4 methyl non 2 ene. And this problem has to uh, write the enantiomers, identify the enantiomers and the diastereomers. So the enantiomers are the non-superimposable mirror image molecules. So this one, this S is a mirror image of this R, and here the S is mirror image of R. So I would like to name these molecules with the letters. This is if you name this A, this is B, and this is C, and this is D. Therefore, what are the enantiomers? Enantiomers are A and B, because this is S. It's a mirror image of the R. Therefore, A and B are mirror images, and also C and D are mirror images. So, what are the diastereomers? Diastereomers. Diastereomers are stereoisomers that are not mirror images. Therefore, if you consider this A and uh, it's a diastereomer of C, because A and C both are stereoisomers, but they are not mirror images. And also A and D, and B and C, and B and D also. Therefore, diastereomers are A and C, A and D, and also B and C, and B and D.